What happens that uh, when when recording gets started, by default, system can remove one or two persons from the meeting. Okay, I have got the notification. So those who have been removed automatically by the system, I will ask them to rejoin. If anybody uh, has been removed from the system, right? So I don't know. Anyways, so I will ask them to join. Anyways. Hmm. Okay, fine. So let us start today's class. Today we will discuss an interesting, very interesting topic, and it's very important. I repeat, very important topic. You can consider this topic as a core part of the subject. Not only you will be getting 30 to 40% marks from this topic, but also it is very important for the campus interview. Right? I told you, if you recall, I told you that there are some constraints to deal with the static memory allocation, means array. All of you have done it. We have used array uh, for the stack and queue when we implemented stack and queue, right? We have discussed, I think, stack. Anyways, let me ask you that the discussion, that the code for stack and queue is clear to all of you now. Hello.
Yes, sir. Yes, sir.
Yes, sir.
Code for stack and queue you have gone through. I sent the material also to your classroom. It's
Yes, sir.
very,
Yes, sir.
Yes, sir.
so all these we have done using array, means using static memory allocation, right? So uh, but the main constraint is that you know that the constraint of array means you can be asked the question in another way, that what is the constraint of array, or what is the constraint of static memory allocation. Array is an example, as a tool to uh, for this static memory allocation, right? So the constraint is that we cannot resize or we cannot modify the memory size as and when required during execution of the program. I have I had taken the example for your batch. Say, you know, you have the idea beforehand that you are having 62 number of students in your batch. It's an uh, known. It's known to all of you, right? So if we want to handle with that 62 number of records, number of records for you, so I can define an array with 62 size. I will definitely define an array of structure, because the record, definitely we define a record with a structure, because the structure contain heterogeneous types of elements. There will be the student name, roll number, marks, right, date of birth. So these are the different data types. So definitely we are supposed to put all these data fields in a structure. So each and every student will be having this structure. So this structure will be having these fields. So anyways, but so we have to define an array of structure if we want to deal with the records for your batch, because this is it's a known fact that I have the idea beforehand that the maximum number of students is 62. It cannot be increased. But in real life, it generally doesn't happen. Let's say in a railway reservation system or a banking system, we really don't have any idea how many passengers will book will book for the tickets, how many customers uh, banking systems will be having. We don't have any it's unprecedented. We really don't have any idea beforehand. So for these cases, the system means that this software. Software means, you know, that the collection of programs, right? If you put so many programs in a single, in a particular place, right? Means digitally, we build a software. Okay. So in this case, these programs have to create memory dynamically as and when required, right? Just try to understand clearly. I'm talking about the that during execution time. It's not that you have closed the program, then you are editing manually the array of the size. It is not the runtime example, right? I'm talking about the runtime. Your program will be running at the same time the memory will be allocated. But in case of array, whatever memory size we consider, that remains fixed during our execution time. No way to modify the size, right? But in real life, we are to modify the size. We are to allocate the memory as and when required dynamically at execution time. So that's why it is called dynamic memory allocation. So this is what happens in real life. So this is the topic which we will uh, discuss today, right? Prerna Karan, try to join in time, right? Otherwise, whatever I've told you, you will miss out. Anyways, you will follow when you will come to know when you will follow the lectures uh, from the your classroom or from the YouTube. Anyways, so let me start presenting something, okay, to discuss the topic. The screen is visible to all of you.
Yes, sir.
Right. So our topic is data structure and algorithm linked list. Linked list is the topic. So linked list is an example of dynamic memory allocation. Okay. Before I start discussing, let me discuss something about this, that two terms are there: linked list. What happens generally, you people, what you do, that you always try to memorize something, putting some effort, but it is not the way. If you do so, after 6 months or 7 months, you will forget. So if you try to memorize, if you try to put some topic or definition in your mind permanently, what you need to do, you need to think about the concept. Don't go by the definition. If the concept is clear, then automatically it will come in your mind as and when required, right? Especially at the time of campus interview. So linked list, by the term itself, it implies that it is a list. You know that array may also be considered as a list. List means a collection of some elements, nothing else. But there is another term, linked. Why the term has come? See, for example, if I if I declare an array of 10 integer elements, generally we will, means the memory will be allocated of 20 bytes, because you know each and every integer in the Windows platform, you know that the memory management is a part of operating system. Operating system is a separate subject in computer science and engineering, right? So how the memory will be managed, how the memory will be handled by the processor, It totally depends on the operating system you are working with. Windows had Windows have different style of handling. Linux or Unix or Fedora, whatever you say, has its own style of handling for memory management. Uh, so I'm talking about, for example, take the example of Windows, because in generally the operating Linux takes 4 bytes of space to allocate an integer element, whereas the window takes 2 bytes of space to allocate an integer element. Okay, so leave it. Consider that an integer takes 2 bytes of space in an operating system. So if there are 10 elements, if the array size is 10, so 20 bytes of memory will be allocated for that the moment we will declare an array of 10 size, 10 integer elements. If the base address of array starts with, let's say, 1000, then means that first room of the array will have the starting address 1000. Then the second element will definitely have what? Will start from 1000, 1001, 1002. From 1002, the third element will start from, they will have the location 1004. In this way, it will be continued, because the definition of array, array is a collection of homogeneous elements arranged in a contiguous manner in memory. Contiguous or continuous means consecutive memory location, the elements will be stored, right? But in linked list, since the spaces, memory spaces are not allocated at a single point of time, or all the memory spaces are not allocated at a time, it will be allocated as and when required. So each and every element of the list must have different locations, right? Are you getting my point? In case of dynamic memory allocation, whenever the system requires to allocate a memory, the memory will be allocated in different spaces. Let's say we are allocating memory for 10 elements dynamically. So here also 10 multiplied by 2, because each element takes 2 bytes of space for integer. Here also 20 bytes of space will be allocated. But these 20 bytes will not have the consecutive address, these 10 elements. These 10 elements having 2 bytes each will have different locations. I mean, it will be arranged in the memory in scattered way, not in consecutive memory locations, right? Let's say the first element will have, if it gets, let's say, 1000, the second element, when we will try to add with the first one, the second element may have 6000, the third element may get 2000. So in different memory location, the elements will be added. Now the question is, how will you keep track which element is after what, right? So definitely there will be a linkage between the nodes, between these elements, so that we can keep track which one is the first element, which one is the second element, which one is the third element, and which one is the last element. Because these 10 elements have the different memory locations. So we have to establish a communication, we have to establish a link between the elements. Otherwise, we cannot keep track. Is it? That's why the term came linked list. So a list will be prepared, a list with the number of elements will be prepared having a linkage in between the elements. Here we will not call the element, rather here we will call each an element as a node, N-O-D-E. In so many domains you will get this term node in communication, right? In your electrical circuit also. You have heard the term node, na? Hello,
Yes, sir.
electrical circuit also. I don't know. Yeah, do you follow Parker-Smith for electrical to solve the problems on electrical circuit? Have you heard the name Parker-Smith? Hello, I'm asking.
No, sir. No, sir.
No, sir.
Parker-Smith is a very popular book, the world famous book. If you want, you can have it. It's very important. So many problems you will get in your gate exam or in some advanced exam from the Parker Smith, and you will get the solved book of Parker Smith also. Parker Smith is very popular one. Anyways, nowadays, hardly an university recommends this book. Anyways, so in your electrical circuit theory also you will get this term node. So node is can be treated as a different entity, as a separate entity, right? But there must be, we can categorize the nodes, right? For a particular category, all the nodes will be having same characteristics, right? Anyways, so now let us uh, proceed with the presentation. So a linked list is a consequence of data structure which are connected together via links. Just now what I said, right? Connected together via links. The data structure, a data structure means it may be an integer type, it may be a float type, or it may be a collection of multiple data types, integer, float, if it is considered as a record of a student, right? So each and every record will be considered as a single node, and all the nodes will be connected with each other to get a link. Okay, so linked list is a consequence of links which contains items, means the data part we call items. Each link contains a connection. Okay, I'm not reading out, so here let me go straight to the here. See, so a linked list mainly has two components. Linked list means a node. A node mainly has the two components. One is the data item. These data items, it may be a single data or it may be multiple data. You can handle with a single data, it may be integer or a float or character, or you can handle with the multiple data. Let's say I just told you the record of a student. Here in data items, you will get, so you can put so many attributes, so many fields, student's name, student's roll number, student marks, student date of birth, whatever is required, you can fill it. Okay. Like say employee ID, employee name, employee address, employee post, employee salary. Okay, all these data. So these are the different nodes. And there is another component which is very important, which I told just now about, that there must be a linkage between the nodes. Let's say this node, this is our first node from of the linked list. Let's say this node has a location 1000. The memory address means base address of the memory. Let's say it's 1000. Okay. Let's say it is 2000. So how to connect this node with this one? There must be a field which will take care of this. So this is a field which contains the address of the next node. That's why the term came next. Here also, after this node, if we want to add this node here in the list while creating the list, well, the dynamically this memory will be created. Let's say it has got an address of 5,000. So here the next will hold the address 5,000. Means like a chain, okay, like a chain. When the chain is prepared, your necklace, so if the different balls, okay, or all different your rings are linked with each other, ultimately it gets a form of a necklace. So here also, in the same way, we have to keep a connection between the nodes to get the linkage. That's why it's called linked list. Okay. The first node of the linked list is called root node or a head node. Head, head node. And the last node is called the tail node or last node. How we can claim a node is the last node of the list? How? Because the next field of the last node must not be having any address. No, there is no node after this node. So it will be a last node. So this must be a null value. Null means zero. Nothing will be assigned here. Means the node, the list is terminated here. Like a string. We have gone to the string in C. To terminate a string, the last character is null character slash zero. Slash zero is a character called null character which signifies the end of a string. Similarly, the next field, if it gets a null value, means this is the end of the list. This is the last node. Okay. Now, this is another variable of, we call it head or root. It is called root node. Here head or root, we can give any another name as a root. Head or root contains the address of the first node. Now get the difference between the root node or head node or head. Head or root contains the address of the node, but the node is not an address. Node contains some data. Node contains, I told you, node contains two components. One is for data items, the data we want to put here, and another is the address, which will be having the address of the next node. So node is a complete unit of these two components, but head or root contains only the address of a node. Here, since it is holding the address of the first node, we can call it that the root or head. Okay. Now, as per the above illustration, following are the important points to be considered. Linked list contains a link element called the first. Each link carries a data field or fields and a link field called next. That is what we discussed earlier. Each link is linked with its next link using its next link. Last link carries a link as a null to mark the end of the list. This all we have discussed. Now there are so many types of linked list. Okay. Broadly, linked list can be of three types: simple linked list or single linked list. You can get the term single or simple. This is the example of simple or single linked list. Doubly linked list we will discuss later. Okay. Circular linked list also another type of linked list we will discuss later. Now we have to know that how to create this linked list, how to manipulate this linked list. The total manipulation we will The total manipulation, this operation, we will divide into some sub operations. We'll divide into some sub operations like insertion. Adds an element at the beginning of the list. We can give a name of the operation as insertion. Deletion deletes an element at the beginning of the list. Display displays the complete list. Search searches an element using a given key. Okay, let's say I'm searching for a node having a particular data item. So I have to search the list right from the beginning. I have to traverse, this is called traversal of a list. I have to search this link from the right from the beginning to the end. And if we this way, if the element if that data we want to search is present, then we can find. Otherwise, if it is not found, then we can say that that data is not present in the list. So searching is another important operation, searching. And delete an element using a given key. See here, it is not mandatory that you have to give these names. You can prefer another names also. Like say instead of insertion, you can give another name, add, okay, or create. The operation which creates a list. Creates means that every time if the create function is called, a particular node will be added to the existing list. If there is no list created, the node you will be adding will be a root node or first node, right? Got it? So these are the sub operations we have to study. Okay, let me ask you one question. Let me ask you a question. That what kind of, now what will be the type of node? What will be the type of a node? You know that there is some primitive data type you have studied, integer, float, or character, right? So when we will define or when we declare a node, which feature of C we will use? Who will answer? Who will answer? My question is, let's say to declare an element, integer element, we write int then variable. For a float variable, float a variable. Similarly, these nodes definitely will be having a variable, right? So what kind of variable this will be? And how we will define a node in our program? Could anybody answer? If you just think,
Don't know, sir.
huh? Somorendu.
Don't know, sir.
Sir,
Hmm?
float.
Float. Why float?
Sir, int and float আছে দুটো দিয়েছি
Int and float, both these two, right?
দিলে variable হবে ইন্টটাও শো করে দেবে ওখানে
No. Anybody else? Try to answer. I told you that you have to try answering. It is not, it doesn't matter. Always you will be telling right, but you have to try. Right? Are you listening to me carefully? All of you? Those who are
Yes, sir. Yes, sir.
Yes,
just
sir.
5 minutes or 10 minutes ago, I had seen that a student has left the meeting. I don't know from this if it is a mistake, it is a technical issue or not. But still, I repeat that those who will attend the entire session will get the attendance. Those who will leave, just joining, will not, should not think that he or she will get the attendance. You have to be present the entire session, okay, to get the attendance. Anyways, so merely getting attendance, I am not. I don't emphasize in attendance, but still, it needs also because we have to keep a track for the students who are not attending. But I want that you have to be present mentally, not physically. so that whatever discussion will be there in the class, you have to understand, right? If you don't understand, then merely attending the meeting will be of no use. Anyways, so my question was, what will be the type of the node? See, I repeat, here I told you, let's say, for example, I told you you can put so many data items, integer, float, character, okay. And let's say even a node contains a single data, let's say only integer number, a integer variable. If it contains, then also this next variable, these variable must be present to establish the link between the nodes. So at least two components must be there. Two components means two variables must be there, at least two types of variables. If it becomes an if I have taken an if I take an integer element, I must take a variable which will hold the address of the next node. Now my next question, what kind of variable can hold the address only? There is a difference between a normal variable and another special type of variable which can only hold the address of another variable. So now my question is that what kind of variable can hold the address only? Anybody answer? What kind of variable? Generally, normally a normal variable can hold a data, integer data, float data, character data. But if I want to store the address of a variable, then how I have to declare the variable? This is a special type of variable. What is the name of the variable? What do we call it? Could you recall?
Sir, pointer.
Exactly. Who is this? Chirojit, that's absolutely right. Good. Pointer variable. You haven't studied pointer variable in C? Or pointer variable can hold the address of a variable. And this pointer variable is very necessary to write a function. I want you to recall an example that when you must have done this program, that is the swapping the content of two variables. You must have done it, right?
Yes, sir.
You can recall it, swapping the content of two variables. You can do it in the with two ways. One is call by value and call by reference. If you use call by value, then the swapping of the main variable, swapping of the content of the main variable will not be affected. It will remain unchanged because you are not changing the actual value of the actual address, because you are doing it in the body of the function, right? So in this case, to get the change affected for the main variable, from where that swap function will be called, the one function you must use call by reference, means you have to send the address of a variable rather than sending the value of the variable, right? So call by address or call by reference you must use. So which kind of means you are passing an address. So the function arguments must be having the type of pointer type. Otherwise, how it can hold an address, right? In the functions, we will be having ultimately the address of the variable, na? Got it? So this must be a pointer variable. So pointer variable is a variable which can hold only the address. It doesn't hold a simple value, right? Got it? So here the next field, here the next field actually, if you go through, this next field actually is having an address of a node, right? Of a node of same type, right? So this must be a pointer variable. So at least if you even a node contains one data item, there must be another type of data which is, that is pointer type. So you are handling with the heterogeneous data type. So how to put these heterogeneous data types in a single unit? Definitely only a structure can do so, right? Isn't it? In array, we can only put one in the same type of data elements, but only in structure we can put heterogeneous types of data, isn't it? So
Yes,
our
sir.
node must be of a structure. Means we have to define a structure for the node. Got it? Where the data will be taking, data will be there, and another variable will be there. It's called next variable, which points to itself, which points to a structure of the same type. Okay, so it must be a structured type. This was my question. Okay, now to insert an operation. Here insertion means, here if we want to insert a node between the two nodes in an existing list, let us assume that this list is present already. Okay, now if I want to add a new node, if I want to insert a new node here, okay, in this place, then what will be the sequence of steps we must follow? Here let's say it is having the address 1000, it is having an address 3000, and the node we are going to insert, let's say it is having an address 2000. Now currently, before insertion, next will be having which value? I told that this is 1000, this is 3000. So next will be having which value? Answer me. Next will be having
3000.
3000. I
Yes, sir.
told you no, that the next field always holds the address of the base address of the next node. Here, after this node, this is the next node, second one, its address is 3000. The next will be having the value of 3000. But after insertion, next will be having what value? Let us assume this contains 2000. So here next will be replaced by 2000, isn't it?
Yes, sir.
Isn't it? Now
Yes, sir.
this will contain what value? 3000. So that this link will be this and this. Okay. But there is a sequence. If you just replace this value from 3000 to 2000, then it will be a wrong one. Why? This chain will be cut off. This chain will cut, isn't it? If you just change this value with the 2000 directly, then how will you get 3000? Because this 3000, this next value, next which was getting the value 3000, will be overwritten by 2000, na? Then this 3000, that the actual value, the initial value, will be erased, isn't it?
Yes,
Hello.
sir.
Then how you will get this 3000? We have to get the 3000 back. How will get this 3000, this value back? So which you need to put here. Then you have to maintain a particular sequence. First you have to do this one, right? Means here first you have to write 3000. Means after this and these two nodes point to this node, right? Got it? 3000, this next field has got 3000. Okay, now it is 2000. Now you can change this 3000 with this 2000. Next you have to do this one. So first you have to get this one, you have to link this node with this one, and then you have to cut the link. Otherwise, it will. This is the only way. Okay, so this is the these steps of sequences are written over here. I have to maintain this one. This just now, that's what I called. First this to maintain, then you can cut the link. Okay, got it?
Yes, sir.
Okay. And ultimately this node will be, new node will be inserted and will maintain the list. Deletion operation is very easy. Simply, if you want, if it is our target node to be deleted, let's say, so it is 1000, 2000, 3000. So it is having 2000 currently. So you can directly change it to the 3000, means this with this. Okay. So this will be deleted conceptually. Okay. Directly you can do this one, do this one. Okay. So this node will be lost conceptually. Similarly, we can also delete this one, the last element, the last node. If I convert it with the null value, okay, then this will end the list. So this will be deleted conceptually. It becomes, if it becomes null value. Okay. Reverse operation, another operation that we will discuss later, where the last node will be the first one and first node will be the last one. The link will be reversed, just link will be reversed. That we will discuss later. Okay, the reverse. So this is an overview of the linked list, which we have to study in detail. The algorithm of insertion, algorithm of creation, a list, algorithm of inserting an element between any position. You can also specify the position here. For example, I have taken that this link, this node will be inserted here. But let's say there are 10 nodes. User can specify, let's say in 8 position, I can insert a new node. Okay. So there must be an algorithm, generic algorithm, like say the position will be taken from the user, and according to the position that a new node will be inserted to that particular position. So insertion, add at beginning, you can add a node at the beginning, then the root or head will be changed, right? The node which is presently as a root, the first node or root node will be the second one after we insert and a node at first at the beginning. Then another new node will be will come, will be our first node or root node, right? So add at beginning, creation, insertion, deletion, right, or display. These are 5 to 6 algorithms we have to uh, learn. Okay, fine. So I am
Yes,
not today. I don't want to continue with the lecture. Otherwise, you will be means fed up. We will not take, I think, anymore. So my question is, I will ask one thing. See, generally the data structure means, I told you that if you in your syllabus only theoretical part is there, it's very easy. I will explain the algorithms. If you just follow the algorithms with the pictures, always the diagram has to come in mind, diagrammatically, right? If you remind the diagram, the algorithm will come in your mind automatically. So just I will give the nodes accordingly, the theoretical nodes, the theoretical algorithm. But my question is, do you want some practical class which is not there in your syllabus? I have already taken some practical classes for the stack or queue handling, right? Isn't it? I have shown you the
yes,
code.
sir.
So if you want to learn how the industrial people writes a code, this code will be totally industry oriented. The code which I will be showing, you will not get in any book. You can uh, follow so many books, but the code which I will be showing you, I'll be giving you, you will not get this code in any other place because it's totally from my industrial experience. I was there in so many years in industry also as a senior software developer or a senior researcher in an DRDO project also. Anyways, so if you want the people, if you want, then I can take some practical classes also. I can show you how we are manipulating the linked list in C. I repeat that this is not in your syllabus, but to get the campus interview for the IT companies, you must know this. So you decide whether you prefer to learn something, to learn how to write code for this algorithm to implement in C in code. Then I can take some classes also. Anyways, first let us complete the theoretical part. At least you get yourself prepared for the exam. Okay. Then if you want, then I can take some practical classes also. Okay. Got it?
Yes, sir.
Yes, sir.
Okay, let us conclude this today's session. I will be giving some assignments for this week also. You are supposed to submit in time. Okay.
Okay,
Okay.
sir.
For
Okay, sir.
today. Okay.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Mm.